Hi, in this video we're going to look at rigorous separator modeling using MySep RunTime embedded in a Hysys steady-state simulation. We're going to look at a production system in Aspen Hysys. The MySep RunTime module is embedded. We're going to see what happens when we add another asset, and we'll watch what happens as we increase the flow from that well. Then we'll review the details of one of the separator models.
Here we see the Hysys model of our production system. Currently, we're taking production from this first asset. The fluids flow into the first stage separator, and the gas and any carryover of liquids goes to our gas compression system. That has two compression stages. There's an inlet suction scrubber and a suction scrubber intermediate to first and second stages. If I now open the MySep RunTime unit operation, you can see that all three of the separators in our simulation are being represented by MySep's rigorous modeling, and currently we have the rigorous modeling activated. So let's see what happens when we add production fluids from our new asset to the system. Note that we've arranged to display liquid carryover with vapour for each of our separators. Now I'll connect the asset. And you'll see the figures have been automatically updated. If I look again closely, they're still relatively low or indeed zero. No worries so far. In our simulation, we want to understand how the separators will behave when we open up the choke valves on Asset 2 and ramp up the flow. We've prepared a case study in Hysys to simulate this process. It varies the flow from a starting value to an expected maximum. If we follow the plots, then we can see in red carryover from the first stage separator, and in blue the MySep RunTime calculated carryover from the first suction scrubber. We can handle quite a significant flow before seeing much carryover from the scrubber. Notice our key results table was also being updated as the study ran.
The details of MySep RunTime configuration and results can be examined inside the simulation. Open up a separator object, click on Carryover Setup, and then click on View Correlation. And we can see the detailed configuration that's been provided in the setup of MySep RunTime. We can also see details of the incremental calculations that MySep RunTime has performed. We're looking at pressure drop and gas-liquid separation parameters through the unit. We also have generated information on physical operational warnings from MySep, and these are replicated inside the Hysys message window as well. In this video, we saw how MySep RunTime modeling can be embedded in a Hysys steady-state simulation. We also saw how the simulation results are automatically updated. We reviewed separator geometric configuration, as well as looking at rigorously evaluated carryover, pressure drop, and process warnings. Why is liquid carryover important? It can be key in many process applications. Thinking about our gas compression example here, it can lead to fouling of blades in centrifugal or axial flow compressors, leading to a reduction in pressure ratio and polytropic efficiency, and hence to large losses in production. With large droplets or large liquid volumes, carryover can lead to catastrophic failure of the compressors, resulting in downtime, lost production, and replacement costs. Thank you for watching this video on MySep RunTime in steady state simulation. As well as Aspen Hysys, the functionality you've seen is also supported in Honeywell's UniSim. MySep RunTime also works in Dynamics. To find out more, visit our website or email us at info@mysep.com.